Hello, this is the Tepid Coder. Today I want to talk about conditional statements and loops. Let's get a project started here. Oop. Hey, touch you over there. Alright, so the first thing we'll go over is going to be an if statement. So, an if statement tests two values with some operator. You have some value 1, you have some operation, and you have val2. So, what you can do here is you can say things like if val1 equals val2. Notice that it's a double equal here. You could do a single equal, but that would actually say value 1 equals value 2, and then it would test to see if value 1 is not 0. You could also omit a second term, and if you do that, it's going to check to see if this is 0 or not. If this is 0, then it's false. This won't happen. But if it's not 0, then it's true, which means everything inside of here will happen. So this will execute if the condition is true. So if the condition is false, we just skip over to here. So the things you can do is you can say equals equals, so if this equals it, or you could say if it not equals, so if they're not equal. You could say if this is less than that, if this is greater than that, if this is less than or equal to it, or greater than or equal to it. Those are basically all the options you have. Now, you don't have to necessarily use two variables. You could use a variable and a number. You could use a function call that takes some parameters, and the result of that will be compared. You can compare the result of two functions, other func. Anything that will give you some kind of value, whether it's in a variable or returned from a function, doesn't matter. You can test that on either side. Alright, so I'm going to give some examples. So, things you might want to compare is something like, let's say, uint8t, uint_i, or I'll say value, equals 17. You can say, okay, if uint8 value is less than 10. The value was less than 10. Otherwise, there's an else here. So if this doesn't happen, then this will execute instead. So let's say value was greater than or equal to 10. Let's compile that. Yep. So that should be true, right? Value is greater than or equal to 10. 17 is definitely greater than or equal to 10. So that's basically how that works. Now, for some things, like say we're comparing two structures, we would have to compare every single value inside of the structure. So why don't I do that real quick. Let's say we have struct, I don't know, we'll call it record like last time. I'll even call it user. How about that? So the user is going to have something like, I don't know, for now, let's give it char. Let's see, name. We're going to have 20 characters in the name. Maybe we'll give it like int I age. So I don't even like that. We'll do uint t ui 8 age. They're not going to be over 255 years old, so that should be a big enough number. Anyway, maybe I'll make an initialization function for it. So void initialize user. So user struct type. Okay, user. Oop. Come on. Okay, user dot name. Can't do that to actually copy it in. So we're going to pass char name. Okay, and then we're going to do page. Okay, so we're going to copy in the username. Then we're going to specify that the user's age equals whatever age we passed. So that's looking pretty good. We can now fill a structure pretty easily. Okay, So let's do that. Let's say we have a struct user called user. Initialize it to 0. I like doing that. Okay. Initialize user. So we're going to pass user. Let's call him tepid coder. And his age is going to be 1. Why not? Feels 1, man. Initialize user has these 2 types. So what if we want to say this is equal or not equal to something? What we could be doing is saying if this user dot, sc name. I should start with the age. So UI8 age equals some other user, like user2 UI8 age. So let's do that. We'll make a second user here, call him user2. Call him other coder. And he's 20. Or she. What else? So if that's true, you could say then if user.sc name. Now this isn't going to work, but bear with me for a second. Name. So we can't actually compare these, because what we're doing here is we're testing to see if this array equals that array. You can't do that. What we really want to know is if all of the characters in this name match all the characters in that name. So what we really need to do is we need to check to see, first of all, how long each of the names are. And we can find that by looking at where the 0 is. So when I assigned this tepid coder, it's going to have that plus a 0 at the end, because I'm using a little quote here, right? It automatically inserts a 0 to terminate it. Same thing with other coders. It's going to have a 0 at the end. So what I can actually do is use some pointer variables here. I'm going to say character pointer is my type. We'll call it, I don't know, p1, let's say, equals user dot sc name. Let's also initialize the proper structure here. Okay, I'm going to say char pointer to p2 equals, well, it's a character pointer type called p2, equals user2 dot sc name. So right now, p1 points to the first character of this user right here, which is going to be t from tepid coder, and p2 points to the first character in user2's name, which is this right here. So it's going to point to O. So what we can do here is we can say if p1 is not equal to p2. Now note that I'm dereferencing each of these. So I'm saying the character at p1 does not equal the character at p2. Well, in that case, I could say something like the names do not match, right? Over here, you can see, like, I'm testing to see if the age matches. If it doesn't, I could say, well, the ages do not match. So this is already going to stop us, but we will test this in a second as well. So where am I at? 15 here. Right, it doesn't know strcmp. I'm using this function because I've talked about it in a previous video and why I need to use it, so I don't really want to go over that again. Okay, so you can see ages don't match. Now I'm intentionally doing this in kind of a dumb way so I can explain it step by step, because I haven't got into loops really yet. I know I've used for loops and stuff in previous videos, but I actually want to go over those. I don't know why I used 2 actuallys in a row there. I want to go over those today in more detail. So obviously I'm only testing the first character here, and in reality I wouldn't know how many characters there were to test unless I actually search through somehow. In order to do that, I need to have a dynamically linked, I don't want to say dynamically sized loop, but a loop that has an indeterminate number of iterations. It has some ending condition. So what I'm going to do here is I'm going to talk about a couple kinds of loops, and then I'm going to come back to this problem afterwards. So we'll just kind of comment that out for now. What I'm going to do is I'm going to say I have an integer. It's an 8-bit integer. I'm going to call it I for iterator. I'm going to start it at 0. Now there's a loop called a while loop. It's going to keep happening while what is in here is true. So while, let's say u8 I is less than 200. Okay? In that case, I'm going to say UAI plus plus. So it's going to keep running. It starts at 0. 0 is not greater than or equal to 200, so it's going to keep running. It's still less. 1's less, 2's less, 3 less, 100 less, 101's less, dot dot dot, all the way to get to 199. Once it would be 200, it's not going to run. So if I run this, it's actually going to loop 200 times. 0 is the first time, 199 is the 200th time. So I'm actually going to print out the value, right? I has some value, so you can see it. And I. Okay, let's run that real quick. It doesn't like that, and just clear the scope. Okay. Right, I forgot the 8 right here. Okay. Anyway, you can see it ended at 199 like I said it would, and it's going to start at 0. That is a total of 200 iterations. So that's one way to do it. The way I've been showing, however, is with a for loop. So let's put it in its own scope so I can reuse the variable. So I'm going to say u8t u8I equals 0. So inside the for loop, what you can do is you can define a variable and initialize it to something. That's the first thing. The second thing you do is you test it to see if some condition is true or not. So if this is less than 200, okay, semicolon, then this plus plus. This happens at the end of every loop, just like right here. So this happens before the first iteration, and then before every single loop happens, it tests to see if this is true, and then after the code block runs, everything between this and this, right, it's going to add this. So basically, this is always going to happen. It's going to set that to 0. That's going to be less than 200. So it's going to run at least once. And then it's going to run this code, and then it's going to do this. And then it's going to test this, run the code, do this. Test this, run the code, do this, over and over again. So I'm going to do the same thing here. I'm going to say, this time, for loop. Okay, UI8I, colon, sign, UI8, line break. I'm going to say UI8I. So we'll see it run again. What? Test. So, same thing, 199. This is 0 here. Okay. It's starting to get to be a lot of stuff that's printed out, so I'm going to comment more of this crap out here. Yeah. The thing we could do is, I'm trying to think, there's a couple more things I can show. I'm going to show what's called a goto and a label. So let's say repeat starting here. That's my label, okay? What I'm going to do is I'm going to say I equals 0. And I'm going to say if I is less than 200, go to repeat starting here. So 8I plus plus. This is kind of what you do in like a language like a single language. You have labels and you can jump to them. So I'll put this here. So go to, we're going to say I colon u8. Not going to do that. I have 2 spaces there. No, I don't. Okay. So what's going to happen is I'm saying here's a point to restart. I'm going to print this out no matter what. And then over here, I'm going to increment the value. Let me think here. If it's less than 200, then go here. So 0 becomes 1. 1 is not less than that. I mean, not greater than that or equal to it, so it goes to here. So this makes it go back to here. And then 1, okay, and it becomes 2, and it tests it. So by the time I'm at like 199, it should become 200 and stop. So I think this should work exactly the same. And it does, yeah. Good. So one thing to keep in mind is if you're using this method with goto, you can't define any variables inside of here, like if I do char c, it's going to complain that this would be skipped sometimes by some goto operation. Let's see. Well, it's going to let me in this case. There's some case where it would be skipped. I think maybe if I use it down here, let's try and actually say c equals 10. Now I should probably complain. No, it's still gonna let me. There's some case where that happens though. Well, I can't think of a way to make that happen right now, but sometimes having labels and jumping around causes issues with where you can define variables. People tend not to like gotos. There are some cases where I like to use them in C. In C++, there are less places that I like using them. The main reason I would use it is if I'm trying to allocate resources. Like, let's say I have, I don't know, a file to open. So I think equals f open, you know, some file, that, the data, and then read binary, okay, if I see, like, the file couldn't be opened, I might do, like, go to give up or something. And then you might have a label down here called, you know, give up. And here you would say, you know, if the file's opened and f close the file, you'd say, like, I don't know, if maybe I allocated the buffer and read the file in, the whole thing or something. So let's say, like, LPSC file contents, right? If that was allocated, then free LPSC file contents. Whatever the case may be. You can kind of imagine that at the end of the function, you might want to free a bunch of resources that you allocated, and you're not really sure what you've allocated up to that point. If you didn't free everything at the end in the goto label, and then like maybe do other things on success, like here you're going to return some success value, and you're going to, I don't know, assign some variable to whatever the contents of the file are, right? And you're going to close the file because you don't need it anymore here. So anyway, you can have some successful route, and then you can skip it on any kind of failure. Like, you know, let's say try to allocate a buffer, and if allocating the buffer fails, then, you know, go to give up. It's good for stuff like this, because you can keep all of your errors really simple. You wouldn't have to do something like, if you failed to allocate the buffer, then close the file, then, you know, return, you know, failure or something. And over here, you wouldn't just return failure. So, yeah, here you would just return failure. Here you'd have to close the file, then return failure. And then further down, you'd have to, like, free the buffer and then close the file and then return failure. But instead, all this just happens down here in one spot. It's easy to keep track of. C++ makes it even easier with objects that go out of scope and automatically free themselves. Let's see here. There's one other kind of loop I want to show. I was just trying to think of a good example. And just like the while loop and the for loop, you can use it in pretty much the same way, but we're going to do this loop. It's called a do while. So, I'm trying to think how to explain this. So, kind of like the while loop, it will loop while this condition is true. However, if you notice, the while's at the bottom. So it's always going to run at least once. So how about I do this? I'm going to say unit 8t by I equals 0. Okay, let's just make it start at 0, like I have been. And I'm going to say while UI8 I. And here I'm just going to say print the current value. So do while UI8I, which has some value. UI8. I'm going to say UI8I. Okay. Now, here's the thing. I'm actually not going to increment it at all. I purposely set this at 0 and check to see if it isn't 0. Because remember, if you have any kind of condition in if statement, or any kind of truth statement inside a while loop, or inside of a for loop, like right here, that's the condition. Anytime you have a condition where you don't have any other parameters, it just checks to see that this is not 0. So if it's not 0, it's going to keep looping. It's going to jump back over to here, and then run again, and then run again, and run again, and run again. So in this case, it's 0, and I'm not messing with it. I'm keeping it 0. So it's saying while it's not 0. Well, it is 0, so it's just going to stop immediately. But because this check doesn't happen until after this, it is going to run at least once, even though the value is 0. So, see that? It ran at least once and stopped. So sometimes you'll have a case where you have to run things at least once, but you might not need to run it more than once. That's when you use a do while. Okay, with all that said, now we can finally get back to the issue of comparing two different structures. One of which having, what do I say, an array of values to test against each other. These arrays need to have the exact same values. All the elements in the arrays need to have the same values. So, like I said earlier, I'm testing strings, and these strings will end with 0. So, what I can do is, while p1, and, I haven't shown you that yet, p2. This means you can test more than one condition. If you do 2 ampersands in a row, it's saying this has to be true, and whatever this condition is has to be true. So you could say this not equals 0, right? And this not equals 0. But I'm omitting those, right? So while these are both not 0, which is the current character of the string, because I'm dereferencing it, this points somewhere, dereference it to get what it's pointing at, which is a character type. Right now it's a character pointer, but by putting this asterisk here, I'm removing that pointer, so it's just a char. So while the current character, t, when I start out, is not equal to this pointer being dereferenced, so this character, which is right here, while both of these are not 0, we're going to keep going. Okay, so I'm going to say if p1 not equals p2, right? Then we're going to say it's not equal. So the strings are not equal. Alright, let me think here. So I set this to be 20, by the way, so that the first check for the age will succeed. Okay, let me think here for a second. So this will succeed. It's going to check to look at the name with 2 pointers. While we haven't reached a 0 yet, check to see if they're equal. If they're not equal, then say that they aren't equal. What we're going to do is we're going to break out of the loop. This will actually make the loop end early, even though this condition may still be true. It means we can quit early. So that's a nice thing to know. So at the end of every check, we're going to say p1++, and we're going to say p2++. So basically, point to the next character in this name, and point to the next character in this name. And maybe we hit 0 here, maybe we hit a 0 here, and this stops. Or maybe these aren't equal when I stop. In either case, I'm going to set a new kind of variable. I haven't shown this type yet. It's called bool, or boolean. So this is basically used for true or false. So any kind of check like this is going to return true or false. In C, bool is actually not a real type. It's just like an int or whatever it's defined as. And you have to use all caps, bool like that. In C++, there's actually a bool type like this, and you can get it in C too if you include standard bool.h. I'll include it just because, why not? Where am I? Okay, so B, let's say equal, right? I'm going to say, let's assume it's true for now. But if they aren't equal, we found out, we're going to say it equals false. Oops, not be false. Be equal. Okay, and down here, I'm going to say if be equal. So it started out equal. If it didn't become false because they didn't match, then it must still be equal. So the names do match in this case. Okay, so the strings are not equal. So I was able to loop through the string and find out they aren't equal. Let's make them equal though. So in this case, let's do this. I'll back that up. I'll say tepid coder. The names do match. So that did work. You see I looped through everything. Now, we can make this a little bit easier on ourselves. This is kind of a weird way to test it. So what I'm going to do is, I'm going to take all of this. Oh boy, I gotta try that again. I made a little mistake there with the key input. Okay, I'm gonna do this. I'm gonna make a function. I'm gonna call it bool's return type. I'm going to say compare strings. Or let's even say something more easy to understand. Strings are the same. Okay, const char pointer to p1. Const char pointer to string number 2. Okay. I'm not going to be messing with the values inside the strings. That's why it's a constant character pointer. And I have 2 strings to test. And they're both going to be assumed to be 0 terminated. Okay. So, like before, while both of these are true, I'm going to say, if these don't match the character of the current position, I'm going to return from the function the value false. So I'm going to say they are not equal. But if I make it to the end, then I'm going to say if, and I should have tested this earlier, but I didn't want to get too crazy. Let's see. If p1 or 2 return false. So I'm testing this because one string might end before the other. And if that's the case, then they're not equal. They're not the same if one ends first. Like, maybe I have a string called, like, I don't know, what's a good example? Maybe one's just ABC, and the other string is going to be ABCD, right? So, it would say they're equal if I didn't do this check, even though they aren't. Because the first 3 characters matched. It matched until the string ended. And if either of these strings end, we stop looping. We don't want to overflow the buffer. So, if we didn't return false because the strings aren't the same length, and we didn't return false because any of the characters were different, then it must be that the 2 strings are equal. So, now we can test like this. So, I'm going to say, make this really easy, if strings are the same, yeah, and I test the 2 strings, I'll pass them both in here, then print out the names do match. Otherwise, let's print it. Print it out. Names don't match. There we go. The names do match. Now let's check to see if it works when they don't match. So, see that. Names don't match. So you can see that works. So let's see here. We've tested this to see if the age matches and if the name matches. What I'm going to do now is I'm going to take this code and I'm going to make another function that'll test to see if the structures match. So bool, true or false, basically. What do I call them? Users are the same. Something like that. So I'll have like struct user, user1, struct user, user2. Okay, and what I really want to do here is have reference to each. And I want it to be constant, so I'm not going to alter the data inside the structures when I'm testing them to see if they're equal. Okay. Did not want to do that. Okay. So, we have user and user2. I'm just going to leave the names the same so I can do this. Okay, so I'm going to say if the age is different, return false. No other checks needed. Otherwise, we're going to check to see whether the names are the same. You can say if not, names are the same, which means it's going to do the reverse. Remember, I think I talked about the not operator. So if anything is, how do I word this? So what not does is it takes a number, and if the number is anything but 0, it becomes 0. If it is 0, it becomes 1. You can think of 0 as being false. You could think of anything but 0 as being true. So if this is true, it's going to become false. If it's false, it's going to become true. That's basically what's happening here. So if the strings are not the same, so if not strings are the same, then what we're going to do is we're going to return false. Don't need an else here, because if we return false here, then nothing else is going to happen, right? We're already out of the function. Otherwise, if this didn't return false, the age wasn't different, and the name wasn't different, then everything's the same, so return true. The users are the same. Okay. So now what I can do is I can do this. Say if users are the same, user and user2. I can say this. Print out the users are the same. And if the strings aren't equal, Okay. The strings are not equal. Where am I getting that? Oh, right here. I'm actually going to get rid of that. Right, okay. And if they aren't the same, I need to print something else. So, users are not the same. There we go, users are not the same. So that's pretty good. At this point, I can just test to see if two structures are equal with one function that calls another function. And I will make them equal again so you can see it works. See, users are the same. And the important thing too is you can see that I got rid of a nested condition. Before it was like if, you know, ages match, then inside of that, if, you know, names match, dot. Maybe there's another member, you know, if that also matches, it's going to keep getting further and further, right? You can imagine like this becoming a big triangle that comes to a point, right? It's doing this. You really don't want your code doing this. It gets hard to read. Now, some things I want to show. The strings are the same function is equivalently... What are they equivalently? It's essentially equivalent to something that already exists inside of the string header. So when you include string.h, you get a bunch of string functions. One of those is to compare strings. And what we have here is two strings, right? The name of 20 characters is really just a char pointer, right? That's what a string usually is. And it accepts a const char pointer when you're comparing strings. So what I want to do here, I'm going to replace this call with the one that people would actually use. So there's a function called strcmp, which is string compare. So what we're going to compare is user.scname with user2.scname. Now, the problem with this is it's kind of reversed. It returns 0 if the two strings are the same. If they're different, it returns some value indicating like where they're different or how different they are. It might be I think it might subtract the ASCII values of the two strings, and like it gives you the difference. I'm not sure. But all you really need to know is it returns 0 if it's true, which means I have to negate it. So what I'm checking right now is, are they not equal? What I wanted to do before was, are they equal? And I said if they aren't equal, return false. In this case, I want to say, in this case, this would be they're equal. So in that case, they're not equal, because it returns 0, which is false. Very confusing. So if they are equal, then it's going to be 0. And this is going to not execute this code. So it's going to return true. But if they aren't equal, this is going to return something other than 0, which is true, which means it's going to return false from this function. So that's how that's going to look. I don't know why there we go. There we go. So you can see it worked. Anyway, I just wanted to code this function to test the strings like that. Strings are the same, so I could show you how the loops worked. There's no other real reason that I basically remade string compare. This is what this is, basically. And it's the same as not string compare of p1, p2. Anything else I want to show about loops, conditions? Right, there's one other kind of conditional thing that you can do. So if you're checking a whole bunch of values, some people like to use what's called a switch statement, and you can do a bunch of cases inside of it. So, I'm trying to think how I want to do this. I can't really give a good example easily right now, but I will just show what you can do with it. So let's say I have, I don't know, an int16t, UI16 value equals 5. You can do something like switch UI16 value, and you can say case, let's say 0. Great. Okay, I'm going to copy this and paste it a couple times. 1, 2, 3, 4, 5. Okay. So what happens is, for each of these cases, it's testing it against the value you pass in the switch statement. So right now, I'm checking each of these cases against this value. So this right here is like testing if UI16 value equals 0, right? That's what this is testing. This is if UI16 value equals 1, This is if case 2. You get the idea. I'm not going to type those out for all of them. And what you can do here, the reason I'm putting these breaks, is if I don't put the break, some of these will run into other ones. Okay, I don't want this to be 5. I'm going to make it like a 3. So, trying to think how I can do this without... I only want 3 cases, so I can make it real simple. So, for case 0, I'm going to say US16 value is 0. Okay. For this one, I'm not going to break. I'm going to say it's 1 or 2. And then it's going to break. You can also say default. US16 value is some number we didn't expect, perhaps, right? Okay. What I'm doing here is I'm going to say, essentially, for case 1, if 1 happens, basically just drop down. It's going to do the same thing that this one does. So it's kind of nice that you can have multiple conditions trigger the same operation. This code will trigger for either case 1 or case 2. So if its US16 value is 1 or it's 2, then this is going to trigger. If it's 0, this is going to trigger. If it's anything else, this will trigger. So right now it's 3, which is not covered by 0, 1, or 2. So this is what's going to happen. So I'm going to show that first. Right? With some number we didn't expect. Just like I said. Okay. So I'm not lying to you. So let's try 0. It's 0. See. We'll try 1, then we'll try 2, just so you can see them all. So 1. It's 1 or 2. And finally, we'll try it with 2, and you can see it's also going to print what it just printed. It's 1 or 2. It's the same thing again. There you go. So that's kind of nice. Typically, when I would use a switch statement like this is when I'm doing something like a protocol, or maybe I'm doing some kind of parsing, and there's different ways you need to parse things. Like maybe I see some token. I'm parsing JSON, which is kind of like this. Like here's an object. Inside the object, maybe you have like, I don't know, let's say user. Okay, and that has like some data inside of that, right? And it's like, I don't know, let's say name, which has an integer value, and you have like, okay, it wouldn't be an integer value, it'd be like, my brain's not working well. This would have integer value, so like 100. You know, whatever. Dot dot dot. Maybe there's like some other user 2, right? You get the idea. Anyway, when I see certain tokens, I might have like values I associate with those, like, I don't know, parse type, say object, right? If I see this, I might have some case for objects, and I'll define this for like type 0, and then like parse type array, right? That could be type 1. And if I see something like, I don't know, friends, right? It'll have like Jack, I don't know, Todd, whatever. When I see this token right here, I know it's going to be an array, so that's what I would do. And like, maybe it's going to be something like parse type string. Like right here, I'm seeing a string. Right here's a string. It can be 2, parse type scalar 3. Maybe that's something like an integer. Maybe it's a double. And maybe it's like 100.1. You know? Anyway, I would typically use these types of things. It's like, what is the last symbol I saw? What am I trying to do? And I would put these into each of the cases. And maybe I do the same thing for a string as I do for a scalar. I could let it drop through like that. I don't know. I'm not really writing a JSON parser right now. And by the way, if you are defining values like that, what you can do is you can actually define like this. So, JSON type object 1. You should always wrap your definitions in parentheses though, because if you do any kind of mathematical operation with it, sometimes it will confuse the parser, because it's not literally the value, it's actually just a text replacement you're putting here. So, something to keep in mind. You can do that. There's also something called an enum. Maybe I'll get into that in a different episode. It's become kind of a series at this point. But, yeah. I went over let's see, while loops. I went over for loops. I went over do while loops. I did like even the goto label. I talked about how you can break out of a loop early, although I didn't really show that with an example like a for loop or something. Maybe I should do that now. So I'll do that real quick. So like, if you remember this loop from before, it goes from 0 to 199. Right. So what I'm actually going to do here is, let's say, if right I is greater than or equal to 100. So as soon as it hits 100, we're going to break. So it's going to stop after it's 100. It'll be 0 to 100, which is 101 items. Okay. Or it should. So 0 to 99. Why is that happening? Gotta think about that for a second. Oh, because it does equal 100. It did loop 100 times. It's just I didn't print it. I did the check before I printed it. So now it's going to show 100 for the last value. Yeah, right there. Anyway, you can break out of loops early. Some languages have a nice feature where if you have a loop inside of a loop, like, you know, for here, you know, I equals 0, I less than 10, I++, you're doing these things, right? They have a thing where you can do like break 2, right? Where I'll break out of not only this loop right here, this for loop, but it'll also break out of this one. You can't do that in C though. And you also can't stick a, what do I say? You could stick a label over here, right? Like, after both loops, you know, you could say something like, go to after both loops. Something like that would work, you know. So that's fine. But yeah, I think I'm going to leave it here. Thanks for watching. Like, comment, and subscribe, whatever people do.